Okay, so I attempted to do a couple of things with this factor analysis lecture. One is to talk about factor analysis and give you a conceptual understanding of factor analysis while keeping it sort of, accessible, not super math oriented. Okay. The second thing is I wanted to try to tie factor analysis together with this idea of classical test theory and to show that there are parallels. And I remember going through, when I was originally putting this lecture together some years ago, that there really wasn't a lot out there that actually did a good job of tying this together. And so I was able to do this. And I've had students that have had more advanced courses in factor analysis and stuff, and they've talked about how much this lecture actually helped them to understand the conceptual things behind factor analysis and tie it together to test theory and psychometrics sort of in general. Well, they for a long time saw it as two separate things. So I'm going to try and do both those things at the same time. Give you conceptual understanding and help you sort of tie it together to classical test theory and other types of psychometric testing, so you can keep it all in sort of one sort of umbrella of information. All right. So far we talked about defining psychometrics, we talked about some history, we talked about basic inferential stats and norms, correlation, regression, validity, reliability. We talked about item analysis. I don't have that on there, but we did that too. And let's try to sort of put stuff together. What's the goal of psychometrics? What's the whole point of psych testing and doing all this stuff? We want to be able to measure and quantify psychological phenomena. That's the whole point. There are things that we can't measure directly, so we're trying to give them an operational definition, and that operational definition, when using things like factor analysis or even classical test theory, is just a more complicated, more complex way of doing operational definitions, where we're not just using a single item to define our variable, our dependent variable, or our measure. So we're trying to use measurable, quantifiable items like questionnaires, behavioral observations, to capture some metaphysical or at least directly unmeasurable concept. So these are things we can't just measure. Not like height, where I can just tape measure. These are things that are unseen, metaphysical things that are primarily the focus of psychology. And I think I've referred to them, or I may have said it in here too, as referring to them as ghosts, right? That we're essentially, the social scientists are essentially ghost chasers. We're chasing things that don't exist, and we show that they exist by looking at the behavioral or other indicators that they exist, even though we can't see it directly. So it's no different than you've watched those like ghost hunter shows, and even though they never see a ghost, they they'll say, oh, we got some EVP, electronic voice phenomenon. They'll talk about the changes in temperature, electromagnetic wave, all these different things that they claim indicate that ghosts exist. So that a ghost is in the house, or the place is haunted, even though we never actually see the ghost. Now, this is not to downplay that psychology or social sciences is not doing a good job, or that what we're doing is sort of hokey or make-believe. It's just in the same way that we have to collect a lot of sort of related evidence of things, questions like about depression, right? We answered multiple questions. We're looking at the holistic view of all those things together as a reflection of depression, in the same way that these ghost hunters look at a collection of different phenomena going on, saying, look, this is too weird for all this stuff to be happening at the same time, so there must be something that explains this. So if a person has a sort of constellation or a cluster of responses related to depression, well, we're saying the reason why is because they are depressed, and that's why they're responding in that way. So the whole point of psychometrics is trying to figure out a way to measure not only things we can't see, but things that are actually fairly complex and reflect a lot of different behavioral and cognitive sort of indicators. Great. That was a long way of saying we got a tough job. We're trying to operationalize things that are rather complex. So to reach this goal, we need, as we talked about through classical test theory and things, we need items that actually relate to the concept that we were trying to measure, right? We call that validity. They relate to the thing that we're trying to measure, right? And for this, we use correlation and prediction to show criterion like concurrent and predictive, and construct, convergent, and discriminant related evidence for validity. Right? Note that the criterion is used in criterion-related validity is not the concept directly either, but another way of sort of measuring the thing that we're trying to measure. So we're doing this a lot. We're like measuring things and comparing them to the other measures of the same thing, and trying to come up with some way that we can convince other researchers, other people in the field, that what we're measuring is really the thing that we're measuring. So validity is a tough one. Sometimes it takes it can take multiple publications, multiple rounds of research before people really start to catch on, or to have confidence that there's really a valid scale or a valid measure there. And things like content and validity is sort of decided separately, usually by experts in terms of what the content should look like, etc. Okay. We also need items that are consistent. They need to measure the construct across samples and time, and are consistently related to each other. So I'm summarizing this because I want you to get an idea of sort of how difficult, how complex this sort of sounds as a job for us to do. We got to have things that we can prove it's valid. We can have at least have evidence that it's valid. They need to be consistent across samples of people. They need to be consistent across time, and they need to be internally consistent with one another. We also use correlation for this. We use test, retest reliabilities, parallel forms, split half. And we talked about the variance sum law and how we can use that to estimate coefficient alpha to measure sort of internal consistency. We even talked about ways of calculating the number of items needed to reach a desired reliability by just simply adding more similar items till we get to a point where we are convinced that the scale is reliable. All right, so we talked about all these different ways of testing and increasing our reliability. And we even talked about how reliability is then the almost like a cornerstone, or at least a foundation for validity, because without reliable measures, you can't really have a very valid measure. Okay. Why do we want consistent items? Well, the reason why items have to be consistent across time, consistent across parallel forms, internally consistent with one another, is because of this idea of domain sampling theory, right? It says they should be. If all the items are coming from the same domain, they're measuring the same thing, then they all should be related to each other. It just makes sense, right? If the items are reliably measuring the same thing, they should all be related. I just said that. Because we often want to create a single total score for each individual person. This is the scaling part. We want to be able to scale people from being not depressed at all to being very depressed, or to be clinically depressed. We want to be able to put them on a continuum, a scale that says, low to high depression. So all the items need to be measuring depression in some way, so that when we add up those items, that total makes sense. It actually is a reflection of the thing we're trying to measure. How can we do that? How can we actually create a total score for each individual and trust that it is really measuring the same thing, and that total really reflects the trait we're measuring? Up until this point, we talked about Chromebox alpha, and you'll still see this in a lot of publications where they'll talk about a scale like the Beck Depression Inventory or something, where they'll talk about the Chromebox alpha of that scale being high. Like, oh, it's 0.8, 0.82, 0.9. It has a high internal consistency. And then use that as an argument for why it's okay to sum the items up to get a single test score. So the rationale goes like this. The items are consistent. They're all measuring the same thing. So we should be able then to add up the points for each one of those into a single cohesive scale. Back to scaling again. But there's an issue there. And I'm not sure if you're thinking about it, because I know this is sort of, we're getting into sort of some of the weeds and details. But the issue is, if I want to create a scale that measures depression, and I've found out that all the items are internally consistent, but if I just add up the items, I'm making an assumption that maybe seem kind of strange. So think about depression items. You have items like, I sometimes feel sad, to I have gained/lost weight in the last 6 weeks. Okay, I no longer enjoy the things I used to. You have items like I've considered committing suicide. To just add up all those items into a depression inventory is assuming one big assumption. It's assuming that all the items are equally important. So they may be internally consistent, but to assume that every item on a scale like that, it's basically saying they all have equal discrimination. They're all perfectly discriminating of depression. And we just went through a whole lecture about looking at social anxiety on the MMPI and saw that there's a wide range of discrimination across the items and social anxiety. So why would I want to just add up all those items and pretend like they're all equal when we know for a fact they aren't? Some of them are better at predicting social anxiety, just like with depression inventory. Some of those items are better at predicting depression or are more discriminating of depression. So why would we ignore that? Couldn't there be a better way to sort of figure this out? So this is the problem that I'm talking about here, that if I want to create a composite item, I want to create a depression total, right? A composite for depression. The way that's typically done is to just add up the items. If I have 20 items, I'm going to take item 1 plus item 2 plus item 3 all the way through 20. In that case, the K, item K. And calculating a total score for any individual is often just the sum. We just sum them, which is essentially saying I want to weight each item by 1. 1 times item 1 plus 1 times item 2 plus 1 times item 3. Right? I'm just pretending that every single item is equally important. And by important, I mean, when you hear me say important, equally discriminating. That they all relate to the composite, the total, in the same way. And you're like, wait a minute, we just talked about how that's not true. We just talked about how different items are more or less discriminating. So why then do we just add up items and make a composite and ignore that fact? Okay. So is there a reason to believe that every item should be equal in how well it relates to the intended concept? I mean, the short answer is no. There's no reason to believe that. Unless you can actually go through some iteration of developing a scale or a test and a bunch of items where you can show that they're all equally discriminating, right? They all have the same amount of discrimination. You're never going to have a reason to believe that adding them up is going to be a good way of doing that without sort of ignoring that information that you've already gathered about the discrimination of the items or discriminability of the items. So visually, the way we oftentimes think about things like depression, we think of them as latent variables, right? So just a generic term to refer to variables that we cannot measure directly. They're latent. So we oftentimes, as a convention, will use circles. So when we see a circle like this on a oftentimes in papers or whatever, circles often are the latent variables, the things we can't measure. Depression is a latent variable. It's something we can't measure directly, so we have to use some kind of measures, a scale, some kind of inventory to look at these very related but different behavioral aspects of depression, often to try to measure depression in general, because it can manifest a little differently in people. So to try to put people on the same depression scale requires multiple items to be combined together. So just to see if you guys are paying attention. Again, I apologize for the guys. It's such a bad habit. You ladies, just see if you ladies are paying attention. If this is a latent variable, depression, what do you think these are called? So if the circle there is a latent variable, what would the squares be? What would you call the squares? Well, the reason I ask this is oftentimes when people talk about anything latent, you'll see this a lot in clinical psychology, latent traits or latent behaviors, latent, all kinds of stuff. So there's latent, and then what's the corresponding and sort of opposite of latent? Apparent's not a bad guess. Apparent, this is a latent variable. These are the apparent sort of traits or apparent indicators. It's not a bad one, but it's not typically. So I'll give you. We oftentimes more commonly just refer, if this is the latent variable, well, these are the measured variables. These are things we actually measure. They're supposed to reflect this. But I was trying to get at the fact is maybe to trigger memory or something, that there's latent traits or latent things that are sort of the hidden things. So what do we call things that aren't hidden? Okay, so observable is another fantastic word. These are the observable behaviors. This is the latent trait. These are the observable behaviors. But there's another more sort of technical term that's like the opposite of latent. Latent versus, I feel like this is like a game show. Starts with an M. So they'll oftentimes talk about this in like clinical psychology, where they'll say something like, this person's latent fears, latent phobias manifested. Thank you. So, right. So I'm glad that triggered a memory. So we oftentimes say the latent things get manifested in different ways. So latent is the thing that is sort of hidden and behind, or manifest is the thing that's actually observable. Make sense? So if this is the latent variable, these are the manifest variables. This works perfectly well when you start thinking about it. Like, so if this is, let's say it's, trying to think of something that's, let's say it's a phobia, right? Or even like, let's say it's OCD, okay? Like something like that's an anxiety issue. So you have something like OCD that really, it comes down, it's really an anxiety disorder. Okay, it's an anxiety disorder in which the anxiety, the anxious part the person feels actually is latent. Right? You can't see their anxiety. What you do see, though, is the turning the light switch off and on 4 times each time, or washing their hands 7 times, or these are the sort of manifest things that come up that indicate a person's sort of anxiety as it is reflected in something like obsessive compulsive disorder. Because the obsessive part is really the anxiety. So the obsessive part is the part here, the anxiety that you don't really see. It's the latent part. The compulsions are the things that manifest themselves because of the because of the latent thing, right? You have anxiety that causes you to sort of obsess about things all the time, always constantly worrying. That drives you to do things to try to rectify or to deal with the obsession, and those manifest behaviorally. Okay, that makes sense? It's like OCD is a pretty good latent versus manifest thing, but everything we look at has those two things. If it's a latent variable, something like depression, there are still manifest things, manifest components, even though it might not be directly behavioral, that are still there, like feeling sad, thinking about suicide, not eating as much, not enjoying things. These are all the sort of manifest components, the individual indicators that latent variable exists, the latent variable like depression exists. And that even goes back, really laid back even to the sort of sillier ghost hunting example from before, where we think there's a ghost. Right, that's the latent part. But what we see is the temperature changes, right? What we see is we hear the EVPs, we hear, noises. These are all the things that if you believe in ghosts, believe in hauntings and things, you will claim are the manifestations. We'll even use that word in ghost hunting and ghost, language. It is a manifestation of the ghost that is the latent thing they're trying to prove exists. Right, so the manifest things are the things you can see and can experience, can measure. Latent are the things that are sort of hidden, that usually is the goal. We're usually trying to understand this, but we're left with this. We can't get to this directly, so we have to go through this to get to this. Okay, so go back to here a second. I forgot to mention all the ones. So yes, this is latent. Yes, these are manifest. We're putting together a scale to sort of be able to measure all these things. And what we really want is to measure this thing. So the way we do this is we we don't ever really deal with this so far in classical test theory, right? This is sort of the validity part. These things are measuring this, but we never really get to this. What we get to is another measure of depression or a clinical interview of depression. We get to compare our version to other versions or other measures of depression. What we do is we say, okay, we got a bunch of items, and we do a Chromebox alpha or something, and we're like, hey, they have a higher than for reliability. Let's just weight each one by one, combine them together, and we'll call that depression. Okay, we'll say that the sum of all these items is depression. When really what we want to do, well, we probably should do, we try to do, is, why not just develop a regression model? Just predict the concept of interest with the items that you're trying to use. Why not just, we'll just say, we'll take depression, we'll take a bunch of items we think measure depression, and we'll just predict it. And then it'll tell us which items are better or worse at predicting depression. And we can figure that out. Then we can use those weights, these slopes, to differentially weight the items. Better items will have higher slopes. Worse items will have lower slopes. And each of those slopes would represent how discriminating that item is. Because the higher the slope is, remember slopes are like correlations. So the higher the slope is, the more discriminating the item is. The lower the slope is, the less discriminating the item is. So the B here represents the slopes. And we can even think about A down here as representing some intercept or average depression level that we can actually compute based on our scale. All right, that sounds kind of good. But what's wrong with this picture? Why can't I do that? Why can't I just take my back depression inventory items and just predict depression? Wouldn't that be easy? Just use my scale, predict person's level of depression, and see which items do better or worse. Don't leave me in an awkward silence. What's missing? I mean, we can show that pretty easily. But what I'm asking is, why use these ones? Why not just take our items, predict depression, figure out what these sort of weights might look like, and then we can weight each item differentially. We can say, all right, look, this item has more discrimination, so let's use more of that item to predict depression. What's the problem? Why can't I do that? Why are we developing these questions in the first place? Right. What's missing from this equation? Depression. Depression's missing. We can't take a bunch of items and predict depression if depression doesn't exist. The whole reason why we're creating this scale is to try to measure depression because we can't do it directly. If we can measure depression directly, we wouldn't need the scale, right? We wouldn't need the Beck depression inventory if we just had like a little window on the side of our head that just said like out of 1 to 30 how depressed we are, right? If we just had that window, we wouldn't need to make a depression inventory. We just read the number. Make sense? So because depression doesn't actually exist in terms of concretely, we can't measure it directly, we have to make these items. So I can't just do this. I can't just be like, well, I'll take these items and predict depression. So we do try to do this in these sort of roundabout ways. So maybe what I'll do is I'll take the Beck depression inventory and use that as my measure of depression, and then use the CESD items to predict the Beck depression inventory to see how well the items predict that. But even that's not real. It's like using one measure to predict another. It doesn't quite get us perfectly at depression, but it gets us close. And that's sort of, you can see sort of what the logic is behind validity. I don't really have depression, but I got this other measure of depression. Let's see if my measure relates to that measure, and at least whatever we're measuring the same thing. Okay? So that's a way of sort of increasing people's trust in the validity of the scale, even though it's not perfect. All right, so if depression's missing, I can't do this. Well, what the hell did I do then? So this is sort of what I'd like to do. Instead of just having ones here, let's actually use some weights to figure out exactly how much to weight each item, so I can create a better composite, a better a better measure of the latent variable. By the way, go back to here for a second. So when we do item total correlations, the reason why we do item total correlations is because we're making this assumption that the depression is just the sum of all these items. So we've weighted each item by one, and we've then put them there. And it's a way of trying to get at this idea. Okay, well, let's use the sum of all the items to stand in for depression. And then we can correlate each item with depression and get an idea of what these slopes might look like, or at least a proxy for them. We use the correlations and figure out how related is each item to the total. And that gives us sort of in this direction. We can actually figure out each one of these could be an item total correlation that tells us how discriminating each item is relative to the other items. That's one option. We can just use the total as a proxy for depression and look at each item relative to that. That's basically what we did with the item statistics we just talked about. But there's another problem. Tests that we use to measure a concept construct typically have a moderate large number of items, like from domain sampling, right? We typically use a lot of those. With this comes a whole mess of relationships, lots of correlations, lots of covariances we got to deal with. Alpha looks for just one consistent pattern. So if we use Chromebox alpha as our reasoning, our argument, well, why can I just combine all the items together in depression? Well, because Chromebox alpha said they're consistent. All right. The problem is things like depression. The reason why I pick on depression a lot is because it's complicated. And I think Union at some point had asked me, like, what if there are subscales? And this is right. And I said, we'll come back to that. This is that moment. Oftentimes, scales, especially measuring something complicated like anxiety or depression or something, they have multiple sort of threads within them, different sort of flavors or brands or however you want to look at it of anxiety or of depression that sort of exist within the scale. So oftentimes they have multiple subscales in them, and alpha just looks for one consistent pattern. So if you have a lot of items, 20 items, 30 items, 40 items, 50 items, oftentimes your Chromebox alpha may actually not look so great because there's really multiple patterns within those items. And when you try to fit to just one item, or sorry, just to one pattern, it doesn't work, and alpha comes back looking not so great. And if items are negatively worded or reverse coded, you actually have to reverse them back. You got to like flip them around before you can do a Chromebox alpha, or else it'll totally tank. Because if you're adding up covariances and you add a bunch of positive covariances and a bunch of negative covariances, they add up to zero. It's going to dramatically reduce the covariances. So you have to put everything in the same direction so that when you add up the variances and covariance for the total, you're actually getting a consistent measure of that. All right. So just as an example, the last thing I'll show you today, this is something called the math anxiety scale. It's got 24 items, okay? Just looking at the bottom half, right, because it just repeats. So the ones down the middle is indicating it's the variable, the item correlated with itself. All the other ones, like this 0.696 is how much item 2 relates to item 1, and so on and so forth. Just looking at the bottom diagonal, can you imagine trying to fit just one pattern to that, one Chromebox alpha to explain all of these variances and all of these correlations, covariances, all the patterns here? When I think the math anxiety scale has something like 5 or 6 subscales, sub patterns, the Chromebox alpha is never in a million years going to find that, and it's going to be very difficult to try to show that there's one consistent pattern amongst all of these correlations, which is why classical test theory, Chromebox alpha, those things start to sort of fail. They can only get you so far, and there's limitations before you can't really use it anymore because it really cannot explain all of these correlations, relationships between variables.